So we started. Let's share screen here and let's go. Yeah. Hey, hey. Anyone has doubts in it? I'll start. सब कितने लोग से होगा? How many people solved? How many people couldn't? It's all fine. You,
Sir, I had solved but had a doubt in it.
yeah, okay. I'll go through the
Uh,
question. I'll read. I'll tell the approach. Then ask it. Good. So you're given heights. The person wants the heights to be non-decreasing order, but the people build it as increasing. Now I want to change number. Like I can modify the height of a pillar to a particular x, and I want to like these are my operations. One operation is choose an I, choose an x, change that height of the pillar I to x. Now, what is the minimum number of operations to make the height non-decreasing? So now let's say here you have first you make it you're like it is non-increasing and you make it non-decreasing. Non-increasing means descending or same. So let's say it is this. Okay. Now how can I make it increasing? Well, like a very naive way is 3, you see 2 is here, so I make it 4. You see 2 is here, so I make it 5. I make this 6, I make this 7, and then I make this 8. I can make it as 3, 3, 3, 3, 3 as well because it's still non-decreasing. Like if all of them are same, it's still non-decreasing. So like the intuition comes from this only. If I want to make all the numbers equal, what is the minimum number of time I'll take? So if I want to make everyone equal, like what can I make them to? I can make them equal to 3, I can make them equal to 2, or I can make them equal to 1, right? Yes, no?
yes.
Yeah. So now let's see now to make this 3, I'll have to make all the numbers not equal to 3, 3, right? Same goes for to make 2's, like so for 3, I'll have to make 1, 2, 3, 4, 5. For For 2, I'll have to make 1, 2, 3, 4. 4 numbers different. For 1, I'll have to make 1, 2, 3 numbers different. So that's it. Now, what is the minimum? For 3, I have 5. For 2, I have 4. 1, I have 3. I'll choose this. No, this is the minimum. Now, how do I do this? Like, how do I code this up? It's pretty simple. Make an array. I put them all in a map. Now I get the maximum frequency. Whatever the maximum frequency is, I subtract it with n. Simple as that. Any doubts here? Like if you want to see the code, I zoom in.
Yeah, so am I audible?
Yeah, yeah.
What I did was I took the elements directly in the map, assuming that our map is sorted, C++ map is sorted,
Yeah, yeah.
and just did an n minus the last value of the map, but it gave me WA for some reason. Don't know why.
What like wait, let me see. Here, no?
No, after this one. After,
This one?
yeah.
Oh, here you're doing just first value.
No, it's the last, right?
Yeah, yeah,
The
but
last element.
the thing is the map is sorted with respect to x and you need the max
Oh,
frequency. That's why I'm doing this, no?
Okay, okay.
Frequency का maximum बाद में निकालो because frequency wise it is not sorted. It is sorted I wise. I can be so technically in this question, like when the array is this, your answer will be 5 if you check
So
because 3
sorted
is
with
the max.
respect to key and not value.
Yeah,
Got it.
cool. Now let's move on to B. B, you're given a you want to sort so that like you're given a permutation. You want to sort it so that I is at I. So like basically, if I see this permutation, my main target is 1, 2, 3, 3, 4. Okay. Now, how do I can I transfer like can I convert this to this? Now, my limitations are I can choose two consecutive numbers such that their absolute difference is 1, and then only I can swap. Else I can't swap. So now let's see like this is my original array and this is my file. This is my original. This is my file. Now, one thing to notice is if I have a 1 can be swapped by how many numbers? 2 only, no? I can't swap 1 with anyone else. Yes, no. Hello. Yeah. So basically, I can't swap with 1 with 3 because absolute difference becomes 2. So 1 I can swap with only 2. So like I can have 1 comma 2 only for 1. So if my original array had let's say 3, 1, 2, 4, I can only swap these like if I want to swap a 1 as I can make put 1 here or here. Like I can't put 1 anywhere else, right? 1 wants to go here, but I can't put it here because 2 isn't here. So from this, we like the intuition comes. Ki 1 has to be either like let's say I have 1 has to be here or here. Like 1 has to be here. And if 1 is here, then the fine, move ahead. If 1 is here, I have to have a 2 here. This is forced because then only I'll be able to swap it out. If 1 is somewhere else, that means it's a no. Okay. Now let's say it was like this. आगे का like the array ahead doesn't really matter currently. I swap it. After swapping, what happens? I get 1, 2, and so on, right? Now same thing. 2 can be swapped by 3 only. After I fixed 1, now 2 can be only swapped by 3, right? Now technically, wait. Let's just make this array, which is valid. 4, 3, 5, 6. Now what is like what I'm doing is wait 2, 1. Now I put 1 here, so I have 2 here, right? Now the entire array, if I just subtract 1 with it, like since I've placed 1 here, the problem just becomes I have to solve this part, right? This array. I have to sort this array. If I just subtract 1 from this, I get 1, 3, 2, 4, 5. What I'm doing is I'm changing the problem. First, my problem was sort this 6 size array. After I fixed 1, I have to sort this 5 size array. And same thing, now you see a 1 here. Now 1 has to be either here or here, right? So you just do this iteratively to check if my values are there. Now that's my intention. I'll see the code and I'll explain it thoda better. Yeah. So now in the start, my index is 0 and my current person I want to fix is 1, right? Now I'm iterating through the indexes and my current element. If my current index has the current value itself, so I don't do anything, right? Continue. Now this is my no condition. If my current value is n, like this is, I'll come to this later. But if my index plus 1 is not equal to current, now see, let's say I am here. I want, let's say, cur equals 1, I equals 0. So that means this part is not valid. Now I come here. 1 has to be here, right? Since 1 is not here, 1 has to be here. So I'm checking here. The index plus 1 is not equal to cur. If it's not equal to cur, then I print no. If it is equal to cur, then I'll have to check this also, no? Ki I can swap it with respect to here, like the current number and the current index per whatever number it is. I get the absolute value. I check if it is like valid. If my swap is valid, swap is not valid. My like all these are non-valid conditions. Then non-valid conditions are there. I just print no, or else I swap. And after I swap all of this, I just print yes. Any doubts? Yes, no. Cool. So let's move on to C. C is a very like brute force problem. Like some observations. Wait, I'll just explain the question to all who didn't understand. Let's say I have 1, 2, 3, 4 till 1E6 fillings. Okay, these are fillings. These are my fillings. Now, one filling if I'm choosing has to be used greater than 2 times, greater than equal to 2 times, or 0, or 0. Like this has to be valid for every single filling. Now I have n burgers. Now I have n burgers. In one burger, only one filling. Like 1 to 1. Okay. 1 per. Now the question asks, and the second constraint is, let's say I have filling 1 at index 1, filling 2 at index 2, 3, 4, 5. This distance, like if I subtract 5 minus 1, I get 4. And this 4 needs to be a perfect square. Okay. Now, a very good observation, like very initial observation, which all of you might have had, is just put them together, right? 1, 1, 2, 2, 3, 3, right? Because these differences will be 1. Now, that is true for even case. So, if my n is even, wait, I'll switch off the camera. Yeah. So if I am, huh. So if my n is even, like this number of burgers are even, I can just do this and it will be valid. But for odd case, I have to see how do I fill this up. I need to make three choices, like one filling. Wait, has to be chosen three times minimum, right? Yes, no. By
Yes.
all others, I choose two. Okay. So now, what indices can I choose for this? For this, let's just do a brute force and do a check. Wait. So what I do is, let's say my A is 1. My first index is 1. I need to select two more indices, right? Let's say I need to choose A, B, C for the filling. So what I do is I literally brute force till for 100, let's say.
पाइथागोरियन ट्रिपलेट्स की प्रॉपर्टी आपसे हुई
No, no, no. The property I'll like Pythagorean
हाँ
triplets, that is fine.
3 4 5
No, no, 3, 4, 5. I'll
नहीं नहीं
tell
आई
you.
मीन लेट्स से हाँ तो इट इज 4 स्क्वायर माइनस 5 स्क्वायर इज 3 स्क्वायर तो दैट इज द लोएस्ट पाइथागोरियन ट्रिपलेट तो इसलिए 1 9 and 25 वर्क्स या फिर 1 16 25 वर्क्स
26 पे होता है
Yeah,
0 0
One, 110 26, I think.
yeah, 110,
हाँ
26 exactly. But I'm just
हाँ
telling you how do I come up with. If you don't know Pythagorean theorem, if I don't know Pythagorean triplets, I don't know the property. What do I do? So that is where I do this C minus B. I'll talk about what the check square root function does. C out A, B, C, and now I just do this. Let let copy this. You see, these are the two triplets I get, A, B,
राइट
C. Now, once you see, like, once I find 1, 10, 26. Oh, wait, I'll talk about check square root also. Check square root is basically checking if it's a perfect square. And square root function I've written on my own because it's just better. Like the accuracy of C++ square root function
डू
hinders
यू
a
हैव
lot.
अ टेम्पलेट फॉर दिस
Yeah, yeah.
स्क्वायर रूट फंक्शन
If you have a template, fine, you just do whatever. Now the thing is 1, 10, 26, right? મને હજી 15 મિનિટ લાગશે તમે બનાવીને જાઓ. Hello, yeah. So now
110 20.
1, 10, right? Let's say blah blah blah. And here I have 10, blah blah
ट्वेंटी
blah,
फाइव 26
26. Okay. So I place a 1 everywhere here. Now, how many numbers are in the middle? 8 numbers are in the middle, like between 1 and 10. Correct?
Yeah,
Yeah. Since 8 numbers are between 1 and 10, what I do is, like, I just pair it here 2, 2, 3, 3. These all I can pair, correct? Doesn't really matter.
राइट
Problem occurs here where I have 15 numbers. So I can't have to like all of them together, right? I need to have, let's say, two. with a gap of 4 because 1 ka gap is not possible. Correct? Let's say I'm placing 3, 3 here, 4, 4 here. I'll end up at 25 when I have to put a 2 here, right? Now next to 2 there's a 1. So what is the next perfect square? It is 4, right? So I can put a 2 here. Correct? Wait, 29th. Correct? Yes, no. So now I can have a 4 ka difference here as well. But now there is something better. You see these two values getting wasted here, right? Can't I just put a 2
Yeah.
here and do this? 23, 24.
Mm,
I can put a 2 at 27 and 23. Yes, no.
yeah.
Right.
Hello, can't hear you.
24.
Anshu, your voice is cracking. So if you want to just mute it. Taran, did you understand?
Yes.
Yeah. So that is it. I put 1, 10, 26 here. I put a 2 at 23 and 27. The rest all I just make it like 3, 3, 4, 4. Doesn't really matter, right? That is it. That is the code. So to
But
code
one
this,
question: n is less than 26, an
Anshu,
odd number, then how I can
Anshu, your voice is cracking. Just type it in chat, right? It'll be better because I can't understand anything. I'll get to the code and then whatever doubt you have, I'll come to that. So in the code, firstly, if my n is less than 27 and it is odd, then I can't do anything, right? I need 27 numbers at least. So I do -1 here. If it is even, then what do I do? For every I and I plus 1, I print a the value 1 and then increment. Fair? Yes, no?
Yes, yes.
Hmm. And for all other cases, like for odd, greater than equal to 27, since it's zero based indexing, I'm doing -1. So 0, 9, 25, I place a 1. This is basically 1, 10, 26. Now I need to put 23, I need to put 2 at 23 and at 27, right? So just put that. Now I have a vector tick. I have an answer array. Now my starting value will be 3 because I've used 1 and 2. Now for all these, I just check, no? If my current value is 0, I assign it to val, I assign the next value to val, and I do val plus plus. And this just and this magically just works. I print the answer. Yes, no? Any doubts?
hello.
Huh.
But if n is less than 27 and odd, then how can prove?
Okay.
Let's n is 50.
Yeah. So for the proof only, that is what I did here. Wait. My first value, like for, huh. Now this statement is valid, right? If n is odd, one filling has to be chosen 3 times. Now, since 1 has to be chosen 3 times, I assign 1 to the first index and I'm checking for b comma c. What are the valid pairs of b comma a comma b comma c triplets possible? Okay. The first valid triplet is only 1, 10, 26. There is no other valid triplet. I am just brute forcing here.
Okay, okay. Checking all triplets.
Yeah, I'm checking all triplets.
Okay.
Since there is no other triplet less than 26, I just do this. Simple.
Yeah.
Fair. Now let's come on to D. D is a very interesting question. Overall thing is, let's say I have a tree here, a tree here, a tree here, a tree here, and a tree here. Okay. If I'm starting at here, I can go either here or here. Okay. Since my J is greater and AI is greater. Yeah. So what is the question? J greater and A of J lesser. So A of J should be lesser. Then I can jump here. Okay. Same goes, let's say I am here. I can go here as well as here because J is less than I and AJ is greater than I. AJ, AI. Fair? This is what the question tells me. Now what I need to do is, let's say I'm starting here. I need to figure out the maximum tree I can reach doing these operations. Like, if you can see, I can go here, then I can jump here, right? And this is the maximum I can reach. Can I reach here? No, right?
No.
Because to reach here, I need to have some smaller over here to jump. Or this has to be some greater. And yeah. So one thing to notice, since I want the greatest tree, I'll always jump from a smaller to a higher. Correct?
Right.
I won't be going to the right and claiming it's correct. It's the tallest because I have to go to the left if I'm jumping. If I'm not jumping, that's fine. For here, what is the tallest? I can only go to here. Because I can't jump anywhere to the right, which is shorter, so I have to go to the tallest in my left, right? Yes, no?
Yes.
Yeah. So now the same thing for here. I won't jump anywhere else. I'll just stay here. So here, let's say it is height is let's say these heights is 4, 1, 3, 1, 2, 4, 5. Okay. Now my answer array for this specific thing is, for this I'll go to 2 and then jump to 4. Same goes for here. Same goes for here. 2 also I can go jump to directly 4. 5 I won't jump anywhere else, so I'll go 5. Okay. This is my answer array. Does it make sense? Yes, no.
Yes.
Yeah. Now the entire question is, how do I build this answer array? Okay. So to build this answer array, there is a concept called monotonic stacks. Okay. This question is just application of monotonic stacks. You need nothing else. And stacks, like almost all of you might have like will know because DSA first, like even
Yeah.
first,
What
huh.
what is monotonic stacks?
No, no, stacks you might know, no.
Ah, stack.
Monotonic I'll come later, but stacks everyone knows. And the only data structure I need here is stacks. Now, what is a monotonic stack? I'll come to that. monotonic stacks, like what does monotonic mean? Bolo.
In a single line.
Single line, or is just either increasing or decreasing, right?
Right.
Or is the same, whatever.
Oh,
So if you like let's say I want to keep it only increasing. So what will a monotonic stack have? Only increasing numbers.
right.
That's it. That is a monotonic stack. So a monotonic stack, I'll just tell you, it is a stack with only monotonic increasing or decreasing numbers. That's it. So how will I make a monotonic stack for this entire thing? And what is a like how like okay wait. I'll explain how to build a monotonic stack first. Okay. Let's say I have 2, 3, 1, 4, 2, 5. Okay. This is my array. I want to make a monotonic decreasing increasing stack. Okay. How do I make this? Okay, I'll do iteratively, okay, step by step. Firstly, my stack is empty.
Right.
I add a 2 here. Okay.
3.
Then I add a 3 here.
Pop all.
Now when I see a 1, I pop every single one, no, because it like this 1 is greater than 3 and 1 is less than 3 and 1 is less than 2.
Is this n square?
No, it is not n square, and I'll tell you why. Wait. So the approach is, now I'll remove 2 and 3, I'll add 1. Now I'll add a 4. Now when I'm adding a 2, I pop out 4 and I add a 2 here and I add a 5.
Okay, got it.
So this is a monotonic stack which I build. Basically,
Oh,
like code wise, while stack dot not stack dot empty and stack dot top greater than current,
hmm,
I do stack dot pop. That's it.
right.
And at the end, I'll push.
Push current.
Then later, st dot push current. Okay.
Oh,
This is how you build a monotonic stack.
right.
Now, why is this not n square? Because technically, like the code part is wait.
2
Uh,
while loops. While current
wait.
and current is current dot next.
First, you have for auto current A, correct? Then you'll have that while loop.
Ah,
Then you'll push.
right.
Right? This is the pseudocode. Now, technically, people might say two while loops is n square, but it's not always n. Now, think of it. Now, don't think of it in terms of this code, okay? Think of it in terms of each number, okay? What is happening to one number? It is getting pushed how many times? Pushed once. I'll push this index only once, right? Yes, no? Hello.
Yes, yes.
Yeah. And I'm popping also once. Correct? Now, if you see, once I've removed this 2, I will never check this 2 once again, right? So for each index, I can
Okay.
assume that I'm pushing it once and popping it once.
Hmm,
So total, I'll have 2 into n operations, right?
right.
Approximate.
Hmm,
And these 2 into n operations is 2 into n, not n square. That's it. That is the time complexity of monotonic stuff. Like how do you build this? Fair? Yes, no?
Yes.
Yeah.
Yes, yes.
So now coming to how do I do this for this question? This is my array. Let's do a standard monotonic stack, okay? Then I'll come to the modification. What will a standard monotonic stack be for this? 1357?
Okay. Huh. Right.
Yeah. Now, what does it mean? Like, let's say I store indexes also, okay?
1
One is
comma 2,
a 2,
3 comma 5, 7 comma
5
6.
comma 6. 5,
5,
5 comma 7 and 6 comma 8.
6 comma
7
8.
comma 8, sorry. What this means is for number 0, 1, all of them can jump onto this, correct?
Right.
And 3, 5 means all the numbers from 0 to 0 to like not like 3 to 4 can definitely jump onto this, correct?
What do you mean by 3 to 4? Okay, like, got it.
Indexes, wait, these indexes
Uh,
are wrong. 0, 1, 2, 3, 4, 5, 6, 7.
uh,
So this is
okay.
4, this is 6, and this is 7. Here 0 comma 1 can jump onto here. 3
Uh,
comma 4 can jump like only 3 can jump onto it.
3 can jump over there and 5 can jump.
Yeah, let's do this.
Got it.
0 comma 1 can jump onto here.
Okay.
3 can jump onto here. 5 can jump onto here. But now there's a catch. Wait. If I just do this, okay, after jumping, what is the maximum behind I can go for a 2? I can go 4, right?
Hmm.
For 4, I can go 6.
Okay.
For 5, I can go 8.
Right. For
And for
7 you
7
can go
also,
8.
I can go 8. Okay. But technically, if you see the answer, all of them are 8s.
Right.
Why is this?
Because you can go ahead and behind.
Yeah. So now once you're at, once you know that my max is 4, I can jump ahead here also, right? I can jump
Uh,
onto this 3.
right.
And then when I'm at a 6, I can jump onto this 5.
Right.
So if you see this, you just need
Uh,
one more modification to this entire stack code. Let's just remove all this.
you add the maximum value instead of the actual value.
Exactly. So instead of here, instead of adding 1,
You
I'll
add
add
max till whatever one.
4 comma 2. Now when I'm at a
But
3, no wait, I'll add 3 things,
4
always
comma
3
2
things.
comma 1.
I'll
4
add
comma 2 comma
1, 2, and 4.
right.
This is
2 is
my,
index, right?
yes, this is my index. And this is my max value.
1 is the actual value.
And this is my actual AI.
Okay. Hmm.
Now when I'm adding a 6 here,
Right.
I
So
add
it is 6
I add pura.
comma
6 is greater,
uh, uh,
so I add 6,
6 comma
3,
3 comma
6.
6.
Okay.
Right.
Now when I'm adding a
3.
3, I add
This
a
3,
3,
4,
4,
6.
4, 6. Now I'll pop this value. Boom.
Why do we pop it?
Wait. Now see here, 3 is what? Less than 6.
Okay, got it. And 6 is greater than 6.
So I pop
greater
this.
than equal.
Now I see 6 is greater than 4.
हाँ.
So I pop this.
But why did you pop that? Let's say I have 2 wanting to jump onto 1. So the value would be 4, right?
Hmm? Yeah,
Or
2
let's say
jumps
I
to
have
1. 2 jumps to
a
1, then it jumps to 4, right?
right.
Technically, what I'm doing is, for let's say I have these couple of numbers. This is 1,
Okay.
there is a max value 8 here, okay?
Hmm.
All the other numbers will jump to 1 and then end up at 8, right?
Right.
So since all of them are ending up at 4,
Hmm.
then they can jump onto this 3.
Right.
And since they're jumping onto this 3, they'll jump onto the 6.
नहीं समझा. एक बार फिर से please बता.
Okay, wait. So let's just draw this out. Okay.
I mean, I understood the logic, but
Ha.
implementation may problem.
Yes. So now this is 2, 4, 1, 6, 3. Okay. Now 2 will always jump onto this 1 and then jump onto this 4. Firstly, correct? Like, wait, see. Our original monotonic stack without this modification, what were you doing? This entire range I put to 4, this entire range I put to 6, correct? And aage wala I put to 8. Yes, no? The previous thing we did.
Got it.
Huh. Now, this 4 can jump onto this 3 also, right? And then get to 6.
Okay.
And it's not only this 4, all these numbers which are ending up at 4 will go at 6. Like, by a lot of like methods. Like, बहुत सारा travel करके they'll end up at 6, correct? So since now all of these are ending up at 6, can't I just merge everything and put a 6 here?
Okay.
These
थोड़ा
4,
better visualization कर सकते हैं please एक और बार.
okay, wait.
बस. हाँ.
You understood this 4, 6, 8 ka logic?
हाँ. I understood that.
Any index in this range will end up at a 4. Any index in this range will end up at 6. Any index in this range will end up at an 8. Correct?
Right.
Now you're at a 4. You see a
Okay.
3 here, right? I can jump at a 3.
And so any
Uh,
index at 4 will be at 6.
yeah. And then at the end, I'll jump at 6. So this
Huh.
number will also end up at 4, which will end up at 3, which will end up at 6. Like
Right.
2 will
Huh.
basically if I
2
want
will
to
go to
if I want to go to
4.
1 से क्या है? 1 will go to 4, 4
Huh.
will go to 3, 3
3.
will go to 6.
3 will go to 6. Got it.
Correct.
Huh.
So all these numbers will end up at 6.
Okay. Right.
Now, if I just generalize, I put all this entire bracket as 6. It's the same thing, right?
Right.
Yeah. So why am I popping it here? Is your question, correct?
Huh.
In my stack.
Right.
What does this indicate? This indicates this entire range.
Okay.
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 And my current max is less than my minimum, greater than my minimum.
Okay.
That means all these numbers will end up at 3.
Huh. Okay. Got it.
And since these numbers are ending at 3, they'll end up at this maximum value. Fair?
Okay.
Now see, one more thing to notice is, instead of 6, let's say it was a 3.
Okay.
My max will still be a 4. Correct? Max to be 4 hai na now. Up to here. I'll still pop this because it's the same thing. No? Why should I have a duplicate number here?
Right.
That's it. So in general, if I have, let's say, a minimum, an I and a maximum,
Okay.
and now I am at a current, comma I, comma maximum, I for sure know that this maximum is less than equal to this maximum, correct?
Huh.
because maximum तो I'm computing iteratively, no?
Right.
So this is going to satisfy.
Huh.
This value
But
I
if
need to
that,
check.
right.
My max, if it is greater than minimum, sorry, here.
Max greater than current.
If
Less than current.
max is greater than current,
Huh.
I'll jump onto this, and all these numbers will jump onto this, so I can just store this instead of this entire part, right? I just pop this out.
Right.
So that is it. That is what my code does. I'll do it step by step. I stored 3 values in my stack, okay?
Okay.
Firstly, I'll get my maximum for each index.
Right.
While my minimum is not empty, and what do I need
Huh.
to check? Max greater
Max
than
less
cur.
greater.
Max is at the
Okay.
second index, and cur
Huh.
is my A of I.
Okay.
I
Got it.
just pop all these numbers,
Hmm.
and the same thing, and then I push.
Okay. Got
So
it.
I create this entire thing. Now I store these indices and the maximum values in
Hmm.
an array because
Okay.
stack में wait, stack में I'll have values like I'll have index 1 here, index 5 here, and index 8 here, right?
Okay.
Now abhi 0 and 1, all of them go onto this 1. How will I know this? Because stack में I'll remove this. I'll remove 8 first. Correct.
Huh. Okay.
So it's just for me to easily visualize, I just sort it normally. I put them in an array and I sort it with
Hmm.
respect to index. Now see here, I have index, comma, max value. Because now min value doesn't really matter, right?
Hmm.
I have this. Now what I'm doing, I'm creating an answer array. And I have j starting from 0. Okay. If I reach my index, let's say my stack, my first value, let's say 3, 5, 8 pe there are changing values, okay?
Huh.
Once I've reached
Okay.
I equals 3, I need to update 2, I need to update 1, I need to update 0 with whatever max
Huh.
value there is, right?
Hmm.
So that is it.
Right.
And I'm doing till my answer is 0. If I've already put an answer there, that means I should end there. I should end here, basically.
अच्छा.
Now 0, 1, 2 to hai idhar.
Huh.
I assign this to, let's say, max 1.
Okay.
Now 4 hai. When I'm going backwards,
Huh.
I'll only update 4 and 5. 3 I should not update once again, right?
Huh. Okay. Right.
So that is my stopping condition. Okay, my answer is till my answer is 0, I update.
Hmm. Got it.
That's it. And I increment the j. Now I've used 3, so I go to 4. I would go to 5, sorry. And that is it. You just do this, you print the answer.
20.
Any
Got
doubt?
it. Not yet.
Okay.
We are.
Yes, that is it. Okay, then bye bye. All the best
Bye.
for ICPC tomorrow.
Okay. Did you stop streaming?
What?
Did you stop streaming?
Yeah, no, wait. Bye bye, stream. All the best for ICPC tomorrow. We'll probably do discussion for that there also. So do join in after 8:30 when the prelims is over. All the best. Like, share, subscribe, join WhatsApp, join Discord community.